So good morning to all. I am J.Ranganayaki, Computer Science Departments. Now discuss the topic is theory of automata. So what is the automata? So this is automata for fundamentals. Okay. So what is the automata? So you are using the finite automations machine in the computer science departments. So theory of automata is a theoretical branch of computer science and mathematical calculations. So why you are using the mathematical calculation in your computer science, that is a languages. So it is the study of abstract machines and the computations problem that can be solved using the machines. So this concept, this techniques, it can be used for solving the some mathematical of machines. That a machine is called a automata. So main the motivations of this finite automations is the beginning of developing the automata theory. So what is the automata theory? Is developed by method of describe and analysis of the dynamic behavior of a discrete system, that is can be changed for mathematical of your computer science, that is called a theory of automata. So next, so many terminologies using the automata. So what are all the terminologies using for automata machines is, so first one is a symbols, second one is a alphabets, third one is a strings, fourth one is a language. So what is the symbol? So what is the symbol? Symbols are an entity to or individual objects which can be any letters or alphabets or any pictures or collection of symbols, that is using the any special symbols or entities is used for finite automata machines. Okay. So for example, using for 1, comma, A, comma, B, comma, C, that is hash. So this is for one is a numbers. So A, comma, B, these are all characters, and hash is the special symbol. So all the special symbols and whatever it is symbols can be used for this finite automata machines. It's called the symbol entity. So that why it's using for symbol entities. So next one is the alphabet. So what is the alphabets? Alphabets are a finite set of symbols or finite set of characters. It's called the alphabets. So this alphabets is denoted by epsilon. So what is the epsilon? It denoted of, it is a finite set of symbol. It is a standard symbol for finite automata machines. That is a alphabets. So for example, sigma equal to small a comma b, then epsilon equal to capital A comma B comma C comma D. So these are all what is can be represented for alphabets. So here also represent the special symbols and the numbers, it can be used for alphabets. So next one is a string. So what is the strings? It is a collection of symbols from the alphabets. So the strings is denoted by W, or is a collection of character is called a strings. So one or more concept of string is a collection of characters or collection of alphabets or collection of symbols from the alphabets. It denoted by W or epsilon W's. For example, if epsilon equal to A comma B, so various strings can be used for the string finite automata machines. For example, it's generated from the epsilon or equal to A comma B. So WA, triple A, triple B, so etc. etc. So A is a single spaces. So WA equal to double spaces, that is a double alphabet. So triple A is a triple alphabet. So that is a strings concept. So next one is a language. So what is the language? It's a collection of appropriate strings. It's a collection of strings or it's collection of a finite automata strings is called a language. So all the finite machines, all the automata finite machines can be used for this languages. Since language is formed over the epsilon can be finite for two concept. So one is a finite, next one is a infinite. So this is a main concept using for flat subjects. Okay, that is a finite, next one is a infinite. So what is the finite? same strings. Okay, so same strings or set of strings length is same. That is a finite automata machines. For example, L equal to set of strings of length 2. So all the characters, all the alphabets for only length of 2. So that is called a finite automations. So next is a infinite. So for example, all the that is a all the strings start with A, otherwise incorrect of length. Okay, it can be suited for, not suited for length. Okay, so all the things. See, example 2 is A comma, then double A, then triple A, and A, B, B. So all the strings, it cannot be same as not. Okay, so that is a string is cannot be for same means that is a infinite language. So this two concept is very very important for finite automata machines. So most of the what machines can be used for your subject is finite language and infinite language. So finite language is handling for in some insufficient, but infinite languages is can be used for comfortable and also extendable for your length and whatever it is. It is user friendly of languages in finite automata machines. So next one is a power of an alphabet. So what is the power? So to extend the memory of your finite automata machines. So this power of alphabet is denoted by epsilon. So we can express this all the fall of S1, that is a strings of certain length from the alphabet by using the exponential notations. Your string is can be for extended for your current executions or current running state, that is can be used for power of an alphabets. So for example, L equals 0 comma 1 as a two symbols, so I can use it for only one symbols for the power of an alphabet, that is 0 comma 1. So epsilon power of 1 means can be used for only one symbols at a time. So epsilon 2 equal means double zero, that is double symbols, it can be used for finite automata machines. So epsilon power of 3 means three strings or three alphabets, it can be used for at the time, that is a power of alphabet. So what is the main point of power of alphabet means to extend the length of your strings or alphabet using the exponential notation is called a power of an alphabet. Next one is it is two part of strings for your power of alphabets. So first one is a prefix, second one is a suffix. So what is the prefix of a strings? So prefix of a strings is a strings. A strings is obtained by the removing zero or more trailing symbols of a string is called a prefix. So yeah, all the strings can be obtained by the removing the zero or more trailing symbols of a strings. It represents the capital S. For example, I take the banana. So BAN. So BAN is a prefix of banana. So next one is a suffix. So all the strings formed by the deleting zero or more of the leading symbols of S is called a suffix. For example, I take same concept of banana. So NA is a suffix of banana. So prefix means for example, you take one strings means that is I take the banana. So prefix means is take the BAN, that is a obtained the removing of zero or more, that is I take BAN of prefix. So next one is suffix means same, it is a deleting form of zero or more leading symbols of S, that is a NAN. So last four alphabets is take for suffix, that is called a prefix and suffix. So next one is a operations of languages. So many operations can be used for this finite automata machines. So first one is a computations, second one is a union, third one is a intersection, fourth one is a reversal, next one is a concatenations, next one is a closure Gallant's algorithm. So first one is complementations. What is the complementations? It's over. So over and the alphabets or strings is can be used for complementations. Represent the capital L. That is a complementations. So next one is a union. So what is the union? So let us, it can be over the two languages or two alphabet, that is a combine. So combine with yes two strings or two languages for your finite automata machines is called a union. So what is the intersection? So next one is so intersection, it is used for inter the two languages or two strings for finite automata machines. So next one is concatenations. What is the concatenations? Combine. So combine or join the two strings or two alphabets or two symbol, whatever it is, it combine the both two inputs is called a concatenations. For examples, I take means high strings, that is strings or languages. So language one equal to high means languages two equal to hello means combine means I hello to give the input for two waves, that is high L1, high hello L2. So what is the function supply? Concatenation means you getting output for high hello, that is a concatenation, that is combine the two strings. Next one is a reversal. So what is the reversal? Whatever it is, you languages or strings is given to the your finite automaton, just you give the reversal of, that is reversal output. So you give, for example, you give the input HI, that is high means to get the reverse option means high H. So whatever is you give means you getting output for reverse direction, that is a reversal. So last one is a clean closure. This is a main examples for your finite automated machines. So what is the clean closure? So this languages is can be used for all the functions, that is integrated and then to extend to whatever it is, all the operations is can be done for clean closure functions. This clean closure function, it is used for to extend the strings or languages length and to minimize the memory spaces and to apply the machine's conditions. So all the advanced things can be used for clean closure. So this is a main topics, main operations can be used for finite automata machines. So next one is a finite machines. So what is the finite machines? It is a main important topics of your finite machines. So finite automata is the simplest machines to recognize the patterns. So what is the pattern? It is a standard format. Some machines or some formulas it can be used for. So this is a standard format of patterns. So this finite automate or finite state machine is these abstract machines which have the five elements or tuples. So whatever it is, it uses. Okay. So finite automation which is system is represent the mathematical model of a system with a certain input. So this model so finally give the certain output. So this input when given to the machines, it is processed by the various state. This state is called a intermediate state. So you give some input and then you process it in the machines, get some output. So this output is, it can be intermediate state, is called a finite state machines. So this is a very good example of a finite state machine system is a control mechanism of evaluator. So best example, that is best real example for your finite state machine is evaluator. So this evaluator, how to say the best example? So this mechanism only for remembers the current floor number pressed. Okay, so best example for evaluator. This mechanism only the remember the current floor number pressed. It does not remember the all the previously pressed number. So only used for current status. So it cannot be show for previously, that is old pressed numbers. That is Main example for evaluator of finite state machines. So this finite state machine, it has a set of state and rules for moving the from one state to another state. That is called a transactions. So, but it depends upon the applied the input symbol. So the variations of finite transaction is variation for depends upon your apply the input symbol. So basically this finite machines, it is an abstract model of digital computer. Following the figures can be used for general automations. So this is for example for finite automated machines. How do your transactions, how do your machines is work for the under the diagrams. So first I give the input, that is I1, I2, I3, I4, so till I power n. So next one is state of automata. So all the transactions is done for this parts, that is automata parts. So whatever it is input, that is strings or alphabet or languages, whatever it is inputs given to the machines to convert the automata state. So all the process is done by automata, then to receive the output. So main structure, so whatever it is inputs given to convert the machines, that is a finite automated machine that produce some results of your state machines, that is a finite automated machines. So there are five tuples or five parts using for finite automated machines. So automated machines can be represented for five tuples. So Q, epsilon, del, Q naught, comma F. So Q is a finite set of state. So how many state it can be used for in your problem? That is called a Q. Next one is a epsilon. It is a finite set of symbols is called a alphabet of the automaton. So how many alphabets or how many symbols, how many languages is can be used for is called a epsilon. So all the inputs, all the symbols, all the alphabets, it represent the epsilon. So next one is a del. So it is the transition functions. So that is a flow of one state to others. That is a flow of transaction of your del. So arrow is it represent the del of transition functions. So next one is a Q naught. So Q naught is the initial state from the where any inputs processed by Q naught belongs Q. Okay. So Q naught is a starting state. That is the initial state of your transition diagram. So next one is a F. So F is a set of final state or state of Q. So it is a final state or end of state. So all the that is five to tuples is it is a very important for your finite automated machine. So this tuple it can be used for done or solving the DFA problem and NFA problem. All the problem regards formal languages, it is used for only five tuples. So this is a main important tuples of finite automations. So how can you draw the diagram for using this symbol for applying the finite automations? So first one, what is the transition diagram? So a transition diagram or state transitions diagram is a directed graph which can be constructed as a follows. How to draw the NFA, how to draw the DFA diagram, it can be used for this type of graph. So there is a first point, there is a node for each state in Q, which is represented by the circle. So all the state of Q, it represented by that is a circle. So next one is there is a directed edge from one node to another node labeled by q comma equal to p. So your directed of equal to starting state to ending state, it represents the p. So next point is in this start state is this a arrow within the number of source. So what is the arrows, that is del of transition functions. So last one is a accepting states or final state are indicating by the double circle. So initial status, it represents the one circle. Ending or final state, it represents the double circle. That is only find out the starting and ending the transactions. So these are all notations. It can be used for transactions diagram. So First one is a Q naught, that is a starting stage or initial state, that is a using for single circle. So next one is a flow of arrow lines. So this line it can be used for a transition from one state to another state or one languages to another languages. That is it used for arrow. So Q not borrow of it is a starting state or initial state. It represents the your transition diagram. So next one is a QN double circle. So that is a final state or accepting state. So how to represent the double circle? That is a final state or accepting state of your transition diagram. So next one is a transaction table. So whatever it is you take, okay, that is you draw the transaction diagram and then transaction table is important for your formal languages. So what is the transaction table? So this transaction table is basically a tabular representation, represent the tabular column. Okay, tabular column of your transaction function. So this transaction diagram is based on your transaction table. This transaction table represents the transactions diagram. So whatever it is done, it will easily the state. So there are two text, two arguments. One is a state and a symbol, and next one is a return of a state. That is a initial state. Next one is a final state or accepting state. So main two arguments needed for to draw a transaction table. So some transactions tables represent the following some things. So first one is a columns is a corresponding to the input symbol, that is state or input. So you draw the input or state, you draw the columns of your symbols. So next one is a row is a corresponding to a state. So column is a input symbol, row is a states, entires, that is entire or entities or entires or symbols is corresponded to the next state. So next point, this start states is denoted by the arrow within the number of source. So all the sources is denoted by the arrow mark. So final, this accept state is denoted by the star. Okay. So starting symbols, that is a starting state, it represents the arrow lines. Final state or accepting state, it represents the star symbol. It is a very, very important. For example, so this is a example for your transactions diagram. For example, you check DFA with a epsilon equal to 0 comma, so accepts all the strings starting with 1. So I take two inputs, I take one conditions. I take the two inputs and then all the strings is starting with one. This is for conditions. Okay. So this two input it can be used for to apply the strings of your transactions diagram. So you need that is two input means you need the three state. So you take three input means you take that is needed for four state. You take a four input means you take the five state. So here I using the for two inputs. So that why I is taking for three state, Q naught, Q1 and then Q2. So I take the three state, two inputs and just I checking the our condition. So what is the condition? Strings starting with ones. So your strings starting with one means I just draw the diagram. So Q naught you flow of Q1 starting with 1. So our condition is satisfied. So I finish the transaction diagram. So I Q1 is I put the final state. So our condition is satisfied means I put the final state of Q1. So this is a transaction diagram. So next one is a transaction table. So how to draw the transaction table? I take the column for 1. So that is a state or input. I take two inputs 0, comma 1. I take the three state, that is Q0, Q1 and Q2. So how to flow the inputs? See, you take the input 0 comma 1s. So first I take the state of Q0. So 0 first you take the 0 input. 0 input it can be transaction of any state. Yes. So 0 input it can be transaction of Q2. So Q naught equals 0 input, it can be transferred to Q2. That is, I put the Q2. So next, so Q1, that is, I take one input for 1. So one symbol you transaction any state, yes. So from Q naught to Q1, transaction of one symbol. So just I draw the one symbol, that is transactions from Q0 to Q1. So I put Q1. So next one is I take to Q1. So any transaction is done for Q1 from to any transaction. So nothing. See itself, that is a looping. That is a Q1 transaction itself. So you draw the Q1 itself for 0 and 1. So Q1 equal to transaction from Q1, and then transaction of 1 is itself for Q1. So I just put the Q1 comma 0, Q1 comma 1. So both the inputs, it can be transaction itself of Q1. That is why I write the Q1 0, Q1 1. So next one is a Q2. So Q2, any transaction is for other state, nothing. So no transactions from the Q2 to any other state. So no transaction of Q2. So see Q2. So no transactions. So no inputs, no transactions from Q2 to any other state. That is why I putting the no transition for Q2 of 0, Q2 of 1. That is a main part. So any tables, okay, so any DFA problems or any NFA problems or whatever it is, you take any finite automated machines, whatever it is problem you take means, first you draw the concept, okay, just you draw the, first you draw the 5 symbols of your finite tuples. So all the 5 tuples, it can be used for the first things. So first you write the, what is, first you draw the 5 tuples of your inputs, then you draw the diagram of transition diagram. So once you finish the transactions diagram using the 5 tuples of finite automata machines means, once you finish the transaction diagram, next you draw the transaction table for based on your transaction diagram. So very three important things you draw the finite automata machines. So you take the problem means or mathematical calculation means, first you draw the solve the 5 symbols of using the input. Next you draw the transition tables and then you draw the transition diagram. So whatever it is, once you draw the transition table means you convert the transition diagram, or you draw the transaction diagram to convert the transition symbol. So both are easily way to find out the finite automata machines. It is a very importance for your finite automata machines. It can be used for all the flat machines languages, also programming languages. Thank you.